Now that we've learned about potential difference, current, and resistance, we can continue our discussion and understanding of circuits. We've already talked about current being a reaction to the action of voltage. In order to have current or electron flow in your circuit, you must supply some electrical energy. How much current in your circuit depends on two things. The first, voltage. The more voltage you have, the more current you have. They have a direct relationship. The next is resistance. The more resistance, the less current. They have an indirect relationship. This brings us to Ohm's law. I equals V over R. When in doubt, put I over 1 to help you solve the problems. I equals V over R is on your reference table on page 4. Ohm's law is going to help bridge different parts of circuits together once we start parallel and series circuit questions. Our first example, we have the voltage supplied to a circuit with a resistance of 100 ohms is 25 volts. How much current will flow in this circuit? 100 ohms is our R, 25 volts is V, and we're looking for I. I equals V over R. 25 volts divided by 100 ohms gives us 0.25 amps. Our next example, we have a current of 2 amperes flows through a circuit with a resistance of 10 ohms. What is the voltage supplied to the circuit? 2 amperes is our I, 10 ohms is our R, and we're looking for V. I equals V over R. 2 amperes, put it over 1. If you don't see to cross multiply, put it over 1. 2 amps multiplied by 10 ohms gives us 20 volts. Our last example, we have a 10-volt battery connected to a circuit, allowing for 5 amperes of current flow. Calculate the resistance of the circuit. 10 volts is our V, 5 amperes is I, and we're looking for R. I equals V over R. 5 amps is equal to 10 volts over R. 5 amps over 1, cross multiply, divide, and we end up with 2 ohms. At this point, we can start constructing and building upon our understanding of circuits. A circuit is a path through which current flows from an area of high voltage to an area of low voltage. Again, over the next couple of days, we're going to start to expand on this and break circuits into series and parallel circuits. When we start to draw these circuits, it's important that we use specific symbols given to us to be able to denote whatever we're trying to get across in our diagram. These symbols are all found on page 4 in your reference table. The first that we have are for voltage sources. We have cells and we have batteries. As you can see, they have a different number of lines when drawing them. A voltage source is something that supplies the electrical energy to your circuit. The next, we have different devices to help measure voltage and current. The first is a voltmeter, a circle with a V. This helps us to measure voltage. The next is an ammeter. An ammeter helps us to measure current. Ammeter is a circle with an A. When we're talking about resistance, we have on the top left a resistor that has a set resistance. The top right is a variable resistor. For instance, if you have in your house a dimmer switch for your light, you're able to change the amount of current that goes through that circuit, able to change the amount of light that you're able to have. The last on the bottom is for a lamp. The little squiggles with a circle. This helps us to be able to show that we have any type of light source in our circuit. The last that we have is for a switch. If you want to open your switch, you're not allowing for current to flow. Closing your switch will allow for current to flow, completing your circuit. This is a basic circuit. We have a battery, we have a resistor, and we have wires that connect all of that together. This on the bottom here, this is a battery. I know it's a battery because of the number of lines that are drawn. The battery, they tell us, has 100 volts. The one on the top is a resistor. This has 10 ohms. Sometimes they'll give it to you, sometimes we'll have to solve. We'll do plenty of problems together. When we place voltmeters and ammeters on our circuit, it's important where we place them. A voltmeter must be placed on the outside of your circuit, or else it will not measure voltage. An ammeter must be placed on the inside of your circuit or it will not measure current. This is what a voltmeter will look like, placed on the outside of your circuit. If I place this voltmeter on the outside of my battery, it's going to read the total voltage, which is 100 volts. If I place it on the left, it's only on a wire. It's not on a battery, it's not on a resistor. Therefore, it's not going to read any voltage, so that's 0 volts. If we place the voltmeter across my resistor, this is 100 volts because it's reading the amount of voltage going through that resistor. And again, if I place this voltmeter on the outside on the right, it's not going to read anything because it's only on a wire. I could do the same thing for my ammeter. To be able to solve for this, I'm going to use the formula I equals V over R, Ohm's law, to figure out how much current is in my circuit. I have 100 volts, I have 10 ohms, which means that my current must be 10 amps. If I'm using an ammeter, it has to go on the inside of my circuit, as you can see. This looks much different than this. This is on the outside for my voltmeter, and ammeter is on the wire. This is what it will always look like. No matter where you are in your circuit, you must have a current flow if your circuit is closed, meaning that you have wires connected all the way around from one end of your battery all the way to the other. Anywhere that you place this ammeter in your circuit, you should read 10 ohms. This is a very basic circuit, only 2 components. That means that my circuit will have 10 amperes flowing throughout the entire thing.